to this page. It's on GitHub, so it's public. The link is here. Can you see the link here? Is it big enough? So if you go to this link, it's actually the GitHub repo. You will have everything that I just showed you on the screen. So there's the setup instructions and all the like workshop step by step is also there. So first things first, you have to go to that link. Okay. I hope everybody got a laptop. If you don't have a laptop, then maybe you have to find a friend to share. Yeah. Yeah. Also, you have to tell me like where are you, because like then I would go too fast or too slow. You have to let me know. Okay. So everybody got this? Can I move on? No? Okay. Yeah, you have to tell me, otherwise I would be woo. Also, I think there's no Wi-Fi password, so I hope you can go to the internet. It's fine. Okay, everybody got the link? Yeah. Oops. So if you still haven't got it, maybe you can ask like your neighbor, and hopefully they would show you, or you ask me afterwards. Okay, so if you go to the link, you will see this page, and then if you scroll down, you see all these like setup instructions. We are going to use Python 3.12 today. So I was thinking about using 3. Okay, so first of all, who knows what is the latest Python version? What's the newest version number? 3.13, yes. But today we're using 3.12 because some machine learning library is still not catching up yet. So I think using 3.12 is more inclusive and everything should work fine. So if you are not using 3.12, if you are already upgraded to 13 or you are using something older, then you can try, but you may encounter some issues. So I would recommend if you have 3.12, use 3.12. If you have PyEnv, you can always get 3.12 from your PyEnv, and then you can use it. Also, the last part of the workshop, we will talk about Docker. So if you don't have Docker desktop on your machine, then I think the best, Docker desktop is quite good. If you're like, using Docker, then probably you want to install Docker desktop. All the requirements is actually in the requirements.txt, so you can so everything is in the repo. You can either clone the repo or you can just download things from there. It's fine. Also, for those of you who have heard about UV, so UV is kind of like pip, but it's way faster. So it's getting very popular nowadays. So some people prefer using UV. But if you don't have UV, you don't want to try it today just yet, pip is fine. So it's up to you. I highly recommend creating a new environment when we are doing workshops and stuff, because you don't want it to mess with your working environment and other environments. So far, so good. Okay, so while this is downloading, I have a question for all of you. So who is from Jogja? Okay, so who is from Indonesia? Well, everyone. Anybody who come from another country? No? One? Okay. So I am actually living in the UK, so I fly very long way to come here. I had so much fun, man. All the food is so good, and I don't want to go home now. So, but anyway, so hope that you have everything set up. So can I move on now? So people will just come in. So I will show you the link again. So where's the link? 1 second. Okay. So this is the link. So if you go to this link, you will see all the information. So everything you want to know is actually in the GitHub repo. So for example, let's say today we didn't finish in time, you can finish the rest yourself at home if you want to. Or if you are like kind of, your computer is playing up, you're like, I'm like too slow, or, then you can always catch up. So it's good to go to the link there. And if you have already set up your environment, you're ready to go, you have done your homework, then you can just scroll to the first, exercise to have a look. All the explanation is also there, so it should be quite clear, but we can go through some of them together today and ask questions if you have any. So far, so good? Okay. So again, we are all friends here. If you have questions, you can ask your neighbor or ask me. Let me know if I'm too fast or too slow or anything. So we're very casual today. We are not very serious. So, okay, part one. So if you have the link, you can already scroll down. This is the part one. So part one, we are mainly focusing on just get to know what is Fast API. So who have done some web development before, like Django, backend thing? Fast API of Flask. Okay, so Flask, yeah, I know Flask is very popular. So you can compare like Fast API and Flask, like what's the difference and which one maybe is better for you. So I assume that most of you are doing machine learning and all these things, right? Yes? Machine learning people? Yay! Okay. So yeah. So this workshop, we will assume that you know all these like scikit-learn, pandas, so I won't spend too much time explaining that. We mainly focus on Fast API. So the first part, we get to know Fast API. So one thing that I like about Fast API is that it has this documentation that's already built up for you. So today we can actually use some of it to test out our endpoint as well. So the Swagger UI is an interactive documentation. So you'll see how it works in a bit. So let's start with Hello World. We want to Hello World. So you can just start a directory. I have a lot of things here, but you may not have that many things yet. So start a new directory and then start a main.py. So this is like main.py, or if you clone my repo, you can also go to this file, and we will start working here. So this is the most simple Fast API's application ever. This is actually in their documentation. So it's basically Hello World. So if I put it here, then yeah, I hope you can see it. Is it big enough for the people at the back? Is it big enough for you? So Fast API is actually very simple, like any code. If you put a function, you're like, well, I hope you are writing code and then you put things in function. So if you haven't put things in function, maybe you should start doing it, because things can get very messy if you don't. So for all the functions, you can just create. So you just call Fast API. So this is, if you have installed Fast API, you can just import it. And afterwards, it just as simple as adding a decorator, then you have already created an endpoint here. So for those of you who are more familiar with web development, there are different endpoints. The most common one are the GET. So so it means that it will receive GET requests. So when you load a web page, actually you're sending a GET request to get the information. So then the information, probably the website, it will show you, maybe if you go to the conference website, you will see the time and date of the conference, the name of the conference, schedule. So that's that. So this one actually is the root. So usually like, you know, slash just means that it's root. So whatever domain you have, so today we're running locally, so it will be your local host. Usually it's 127.0.0. something, you know, so that's your local domain. So for example, like when you do it online properly, like Google, we have like google.com. So that's Google's domain. So the root is just google.com. There's nothing after it. But of course, a website have multiple pages and multiple endpoints. So like you won't just have one for everything. So for this hello world, we have another endpoint, also like get. So it will accept get requests at this location. So for example, my domain, let's say my domain is check.dev, right? So check.dev and then slash user slash. So this is actually, oh, why is it? It's kind of like an F string, right? So what it means is that like it's a dynamic URL. So like, for example, someone's username. So like, let's say my username is Chuck. And then this will actually become a variable here, okay? So whatever you type, if you type ABC, then username will be ABC here. So it's kind of dynamic. You can use it as a parameter to do like further action here. So right now we just return it. So the simplest, but later you will see that there are actually like different use of this. So what is Q? Q is actually the query. We'll look into the query parameters in a bit, so don't worry about it too much for now. So far, so good. Good. Okay. So now, when you have this, now let's do it together, right? So like you go to find your terminal here. Okay, so this is the one I use, so clear it out. And maybe I should make it, yeah, I should use everything light mode because presentation like light mode is way better. How can I change it? I am not so sure. I've rarely changed it, so I don't know how to change. Maybe settings. Oh, okay. Can I change it to basic? No, this one. Can I apply it? Okay, 1 second. Maybe let me try this. Yeah. I think I have to open a new one. New. Oh, it doesn't let me go new. Yeah, new window. Let me open a. Is better? Maybe blue is better. No, it's not. Which one you want me to use? Choose one. Huh? Black is fine? You sure? Okay. So now I would, so Fast API actually come with a command line too. So you start with Fast API. There are actually multiple commands there. Usually if you type help, you will see that there are many things you could do. So you can do def or you can do run. So what's the difference? Difference is that if you type run, it will go into a production mode. So that's when you do deployment, you would do Fast API run. But right now, since we are developing, so the best thing to do is to do Fast API def and then the file name. So the reason doing that is that when you do use Fast API def, so if you change the file, so for example, if you change the content of main.py, it will refresh itself. It will deploy again, and so you don't have to, stop it and then save and then do it again. So it's faster. So if we do it, then you will see that now there's a lot of things going on. Oops, I'm using app. Huh? Did I not save? Oh, I forgot to save. Sorry. Let's do it again. So, yep. So if you see this window, it means that it's running. So it says that it's now serving here. So this is my local host, 127.0.0.1. That's my local host, so it opened the 8,000 port, but don't worry about the details. Just know that, like, if we go to this, if you go to a browser and open this thing, this is our root. So this is like the root that we have put it in here, right? No, sorry, there's not too many windows. Bear with me. Okay, so this is the root, right? So if we have nothing at the end, so it will just go into this one, and we will have just hello world. So just give back hello world. So since Fast API is let you create APIs, so it's a back-end kind of tool. The simplest things to do is to just like return a JSON, a dictionary, so JSON format. You could return a HTML file, which means that like it would be more like a web page. But right now we don't do that very much. We are not a course learning how to create your web page, so we don't do that. We just return whatever information we created, so we see that it's working. So, it's okay? Good? Okay. So now let's try out our other endpoint. So we have another one that's a user, right? So user. And then if I have users, and let's say username is John Doe. Yeah, so you see the user now is John Doe. And then Q is actually nothing because we haven't put in any query yet. So let's try the query one. So if you type another slash, oh, no, sorry. Wait a second, let me double check. So where are we now? Because, yep, I don't want to go too fast, too slow. Okay, so here, and then, yep. So for query, so you see sometimes the website, they have this like question mark thing, right? So this is where you can put in your query. So after this John Doe, or you can like, I don't know, you don't, if it's not John Doe, maybe it's a Jane Smith, I don't know, or whatever. But if you after that put question mark, and then since we have one query parameter, which is Q, so Q equal to, I don't know what you put in, maybe hello, right? So just Q will be equal to hello. So this is how query works. Sometimes the endpoint will have a multiple query variable. Right now we just have Q. But let's say if you go to this file and then you go back to the main.py, if you have, let's say, Q, and then you also have maybe P as well, very not imaginative. So now we have two queries. We have Q, we have P, and then we add P here as well. So now you have two query variables. So what you can do, if you save this, if you save, okay, now I've saved, you will see that here, oh, I've made a mistake, sorry. Here, okay. So if you save, then you see Fast API will do the refreshing by itself. So it's very smart. If you do dev into development mode, then every time you save, then it will try to redeploy the application. So now it's redeploy, then we can try the new thing. So instead of Q equals to hello, we can also add another one. So we can, if I remember correctly, is P equals to, whoa. No, actually it's N. So it's like this. So question mark is like saying that the rest of them are queries. So each query is like the variable and then the value of the variable, and then you put N and then another. So it's kind of like this. So now you have hello and world. So I wish I can zoom into this, but this is actually look like this. I can put it here, like this. So you have this. Then now you would have that. So far, so good? Yes, good, cool. Or am I too slow? You already know this, you don't need me to explain it. Okay, so if you're already good, then like maybe we can move on to the next exercise. So Oh, we still haven't tried the documentation. So there's also this thing that I love about Fast API. So if there's a special endpoint that created for you automatically. So it's a /docs. So if you go to the /docs, so it should give you this documentation. Oops, a bit too big now. Okay. So here you can actually use it to try out your endpoint. You can try it out here, and then you can type, username again, like John Doe. Doe, yeah, and then or John Doe or whatever, and then this is hello, world. So you can also do it here, so you don't have to type it in the URL for this specific thing. So if you execute, click execute, you see the result here. Yep, it will say it's okay, it's running, and then you should see the responses here. Here, so it's like you have hello and then you have world. Okay. So this is another very good tool that we could use. So let's go back. Let's move on to exercise 2. So now we would do the machine learning for real. So we would use scikit-learn. So if you go to this Jupyter notebook, actually, here. So this is just an example I have created a long time ago. It's doing some using scikit-learn to do determine what's the species of a penguin by using the length of the beak, which is the mouth of the bird, the bill, and the flapper, the wing, the length of the wing of a penguin. So all these are machine learning. They are just like, I just copied the example of scikit-learn somewhere, and then all these things. Again, I won't explain too much. So this is basically what it does. If you are very curious, you can download this and try it out, but it's not necessary. So we also need to have a data, right? Like we have the penguin.csv, which is also in the repo. So if you have cloned it, you would probably already have it. If not, then you can grab it from here. You can just download it. Okay. So after that, we would create our Fast API. So, but before that, we need the machine learning things, right? So imagine you have done the machine learning part, or your colleague have done the machine learning part. So this is done by a data scientist. So let's put it in here. Okay, so this is your colleague's code or your code that you have already done. It's like, or maybe you grab it from the Jupyter notebook. I don't know. So okay, so this code it should be running fine. Okay, or you can try it out yourself if you don't trust me. Maybe I have a typo inside, I don't know. So now how can we turn this? How can we turn this into a Fast API? So that's what we are trying to do in this exercise. So do you want to try it yourself or do it together? Do you prefer? Should I give you a few minutes to try it yourself first? Okay, maybe I'll give you a few minutes so you can try to make this into Fast API. How would you do it? And then we will do it together after. Okay. So remember, we like everything to be in a function, right? So maybe start by putting it in a function. So it's or maybe start writing a function that do the prediction. So this is how I do it. You don't have to do the same thing. Is that so this is actually so what we do here is that we would, process the data, clean out drop all the NAs, and then we would put it in a pipeline. So this is how the machine learning pipeline work, is that we would have a, first of all, do some encoding, and then we would do the, so we transform it, and then we would do the training using a K-neighbor classifier. But we also want to scale it so it doesn't do some crazy things. So we've scaled it. So this is the pipeline, and then we fit it. So the model is ready to go. But then now we want the endpoints to do the prediction. So this is what I do. So again, this is what very similar to the previous example. We have fast API, so we create a fast API. So this is the prediction function. So this is what we do. When we get the query from the user. So these are query variables because we don't have the thing here. So we don't have this. So these are all query. But the endpoint is predict. So if you don't type predict, I won't do the prediction for you. So in the URL, you have to go to predict, and then you can put in your query. Bill equals to some number, and then flapper equals to some number. And then you will get the parameters. So after that, we can put the parameter into our model here, CRF, which we have trained. So we'll put it here to predict, and then we'll get the result. After the result, we would then give back the answer. So we also need to do a inverse transform because otherwise it would just give you a a vector, which is so what does it mean? Okay, it means that species, right? Okay. So let's save, and then have a look here. Okay, so now it's completed. So it should work, I hope. So let's go to the web. So how about we will try. So again, 1, 2, 7, and then I'll predict. So remember, we have to go to the predict endpoint, right? It won't work if you don't type predict. And then B, let's put in some number. What do we want? 250. So it's in millimeter. So it's 25 centimeters. It's quite big, this bird. Okay. And oh, I forgot the question mark. Sorry, this should be question mark. So and flipper is equals to 300. Let's say. Right? Do I have a typo? No. Okay. So now I have a prediction. So it should be like this penguin. Gen 2, I don't know what is this penguin. I'm not a penguin expert, so I don't quite understand. I just, I'm just an engineer. It's like, okay, this is what, so we have a result. Good. So this is what I do. I can also put this example in the code. Where's my code? Okay. I can also show it here in case you want to follow along. Okay. Or there actually a faster way to do it is to use the documentation. Remember, we have the interactive documentation. So if we go to, remember the URL is docs, right? So if we go back to, okay. So now we have the predict endpoint. We can also try it out here if you don't want to type it, you want to, see what you're doing. You can put it here, also 250. Try it out. You have to click this first. 250 and then 300. And just to prove that it's not random, it should give the same result here. Okay. Right. So far, so good? Okay. Right. So next. So far it's okay, we do this, seems working, but what if someone put in something silly, right? So let's say I'm super silly. I would, what if the bird has a 0, or 0, 0, what would you get? So let's try. What would we get for 0, 0? Oh, we still get a prediction, but, it's probably not correct because what is this? This is a bird with no bill and no wings. It's a strange. Is it a bird? Is it still a bird? So then is wrong. So we need to do some validation to make sure that it's right. Also, what if someone's very naughty, right? Type in something that's not a number. So if number is fine, right? What if someone type in random stuff? Or maybe oh, this is check, right? Does it work? So now we have an error. So, so we have an error, so it must be a number. So we have to now like know how to take care of those things when it doesn't work. Okay. So now it's fine. Now it's like float. So what it does that like for fast API when you put in like here. So if we do typing, so if you do the typing of the variable, then actually you will get this very, very nice error message here saying like, must be a number. Because you already tell Fast API that I only want a number here, right? So even 0 doesn't make sense. It is still a number, so it won't have the error message, okay? So 0 is, it gives something, it still gives you a prediction. It's probably silly, but it won't be like, explode and the whole thing, get an error. And, if you type in something that's not a number, let's say, some characters, it will give you a warning, but it won't crash the whole thing. So this thing is still working. You can see I've been messing around with it, but it's still working. So the least thing you do is that like if you don't do this validation, so let's say if we don't put the float here, so what will happen? So if we don't put the float here, so let's try. So now refresh, do it again. So if I do again like silly things, put in some character that's totally wrong, this time I got an internal error. So there's no validation going on because Fast API doesn't know that this needs to be a float, that needs to be a number. So we would, keep on moving as if nothing happened. But then like, when you put it in scikit-learn or like NumPy, it will be like, oh, it's wrong. Like I got you see a crazy error message here. This is probably from scikit-learn value error or NumPy as array. Yeah. So it doesn't work because I can't convert this into a number. But then this is not good. Then if someone do something like, then they can crash your whole application. It's very easy to hack, so this is not good. So we want validation. So we want to always type your variables like this. So now we just talk about, what if someone puts 0? So what if if someone put in 0 or put in a very silly like, number, for example, like a very, very tiny bird. This is probably not a penguin. This is probably a hummingbird, like 1 centimeter. It's very small. So what if I want an error message instead of putting it into my model to give out an answer that's not correct, right? I want to have the same thing that like, the box saying like invalid and stuff. So how can we do that? And that's what we do here. Then we have to work on the typing a little bit more because before we just tell Fast API, oh, this is a number. Any number is fine. But now we need to tell Fast API, no, like at least don't let people put like negative or 0, right? So here, this is a little bit of thing that we changed the code. We need to add this annotated because we will do more like sophisticated typing here. So that's how we do it. Put it here, let's say. And then we also use this special thing called query. So we'll also put it here. And then we will change our annotation to something like this. So now instead of just float, I use annotated and I use query. So query is a way to put a constraint on the input for you. So now it's gt equals 0 means that it needs to be greater than 0. You can say it's greater than, I don't know what makes sense. Like I'm not a penguin expert. Maybe I have to go find the domain expert and ask them like, hey, what makes sense? What doesn't make sense? But anyway, so let's put 0 for now. Like everybody know, like even people like kids in kindergarten know that like it needs to be greater than 0. So these two greater than 0. And then now, if we go back to our playground and try it out. So now if I put 10 and 10, it should still work, right? So okay, it still work. But what if I put 0 and -1? What happened? Okay, so now, oh, maybe I have to refresh. Yeah, sorry. Yeah, I think I probably have to refresh. 1 second. Let me try it again. Okay, that was 0. I'll put -1. Right. Wait. Oh, yeah. So you get the message. Input should be greater than 0. So this is, again, like a message generated by Fast API because we have used the query to do some validation. That is, so instead of, again, like instead of you have a crash, the whole application collapse and stop working, you would just give the user a error message saying like, hey, something wrong with your input. You put in 0 here. And then the other one you put in -1. No, we don't like that. Do it again. So that is work. Okay, so it's good. This is what we want. This is like, we don't have an internal error. We just tell the user, hey, your query is wrong. Okay? Good. Good. Okay. Let's move on to the next one. So, oh, actually, this is the end of the first session. So let's see the time. Okay, so we only have half an hour. So how about that? Like, I will leave the extra challenge for you to do it at home because we don't have time today. But I will be here like tomorrow and the day after tomorrow. So if you try the extra challenge and have questions you want to discuss, we can do that. But let's move on for now. So now, okay, so that part is finished. So now we have something that's kind of working. You know, the user can come in and like can put in some, you know, parameters, and we can do some like prediction for them. So now we have another challenge that we have when we, let's say, have a meeting with the team, and then the team was like, oh, it's all good, it's working, but we want to retrain the model from time to time. So, oh, okay, now, so how can we retrain the model? Right now, so far our code, everything, you know, so all this training are here, I just put it here. So what happened now is that whenever I do the command, you know, Fast API dev or Fast API run, when it starts up the program, it will run all this code. But that is not good because now I can't, you know, every time I want to retrain the model, I have to restart the whole application. That may not be what you want eventually, because if you have it in production, you can't bring down the whole system and then retrain it, right? So let's do something different. Okay, so there are a few things we will learn to help us to do that. So first of all, we will learn about a thing called the background task. So what does it mean? So background task means that we are now going from, you know, so far we only write sync code. We haven't write async code yet. So who is familiar with async in Python? How many? Only a few? Okay, don't worry, it's fine. It's not too complicated for our use case here. So in async code, actually, so some people will have some misunderstanding. So parallel processing and concurrent, which is async code in Python, are different. So in Python, async mainly is like concurrent, which means that there are a lot of jobs. You can put them into give it to an event manager. So the event manager will assign the CPU to do different jobs. So sometimes they're waiting for this job, like for example, they send out something and then waiting for a reply. Instead of holding the CPU, just waiting for this and then keep going like one by one, it can jump to the other task to do it first while they're waiting and jump back. So a very good analogy is that when you are cooking, right? So when my partner at home, when he is cooking, he is like this. So he is not async code. He's not async cook. So what he does, he would do like one step, 2 step, 3 step, 4. Just very slow. So he will take like more than half an hour to cook something simple. But I am async. So what I do is that like, oh, let's say first of all, when I make rice, I have rice cooker, so I put the rice in the rice cooker, and then while the rice cooker is waiting, I don't have to do anything, right? So I can go and maybe like fry some egg, you know, stir fry or chop the vegetable, you know, and then maybe let's say I'm waiting for the wok to heat up, then I could already maybe chop the vegetable, get prepared. So that's async. So now we are improving our code by making it async. So this is a new task that we will do. So instead of using scikit-learn, now we use Keras. So this is a MNIST classification using the CNN in Keras. Again, this is not a Keras tutorial. I won't explain too much. You can just copy the code and use it. So this is, so we just copy this. And then let's see how we can make it async. Okay. So this is, so far, this is also just sync code. It doesn't have async here yet. So far so good. We have, Keras. It will just train the model, and then we will start the application. Now, what we'll do, we will add the background task. So that's why I said it's not good if you're not putting things in a function. See, like all these things, these are the training. It should be wrapped in the function. So let's do that. Let's tidy it up. So now, instead of just a bunch of things, I would wrap them in training. So I also add some variables, these global variables, to help me keep track of things. So that's what I'm going to do here now. And then I would use this and then put it here. Okay. And then all this code that's training the model should be inside the function, right? And then I have to also save the model in global so I can use it outside of the training, right? Okay. That's how we do it. So now we have everything in training, like in a function. So this is more tidy. It's good. Now we can work. Next. So now let's change things into async. So you see, this is different from what we had before. So instead of just DEF, we have async DEF. Okay. So the difference is that now this will be async. So we would be able to use the background task to train the model. So when you train the model, right? So for example, now I'm still training. The application hasn't started yet. The application is not working right now. If you try to go to, let's say, the application, it should give me hello world, right? I just do the basic thing, it should give me hello world. It doesn't give me hello world. It's stuck. So this is actually, you can't see it very well, but actually it's stuck because this is still training. We don't want that. We want it to be async. So we want it to be like, while this is training, I can still do something. Like, so it's like, this is let's say this is the rice cooker. It's cooking the rice. I'm not going to wash the rice cooker to cook the rice. I can prepare my dish. So so that's what we are doing here. Okay. So the hello world, the root is very simple. You just add async in the front. Let's go there and do it. Where's my code? Okay, here. So this one I just add async. It's very simple, straightforward. And then this is the info. I added this because then you can check how many things are running at the background. Okay. So this is the interesting bit. This is the training API. So now I can train my program in the background. I train the model in the background. So here you see that I have the background task, which I should actually import from Fast API. So if I don't do this, this will give me an error probably. Where is it? Fast API. Okay, we should probably add it here, I think. Okay, before I save, let me double check. Yeah, I need to import it. And then I just add the training, the task, which is running in the background now. It should be like now put in the background task. And then once this is done, you just tell the user, oh, it's running now, it's training, so don't worry about it. And then if they want to check, they can go here and check how many are running, okay? So now let's stop this because I don't need this. Can I stop it, please? Okay, it's like, you see, it's so bad. I don't like this design, it's still running. So it's almost done though, so it's fine. We'll start the new one when it's Let me save this first. Then we won't do silly things. Question, yes? When will the training? Yeah, so if you have this code, so imagine this is the code. So when you start it, so now it should, I want to restart it. So when it restart, actually, it won't do the training. It will just start the application like we do before. It will just like say application completed. But then now, there's the catch, because if you now just do the prediction, then it will just like not working because the model is not trained. That's the next exercise we'll do. So right now, right now you have to manually go to the API endpoint, go to this endpoint. You have to do the train first, then you will do the training, and then you see the model is training and stuff. So I haven't added the prediction yet because that's the little problem. Because we haven't finished yet. This is the first step. Okay? So let's see. Okay, so now you see, like after that, when I save, now it doesn't do the training anymore. It don't do this. It will just say like, oh, application startup complete. So right now, if you do info, here, right? So now it's hello world. Hello world is working fine. Oops. So if we do info, there's nothing training, right? So now there's nothing is training. So if I now type train, so it tells me training mode in the background, like the model is training in the background. So it's training, right? And now I should be able to see info. So it doesn't stop. So it doesn't stop the whole thing. It's still doing it. But it's doing it in the background. So it's not watching the so the application is not watching it to train. It just let it do it at the background, and then it's still serving the customer. You know, you can still ask for information and stuff. So this is the one way of doing it. But of course, there are issues, like what if it's not trained yet, but the user is trying to get a prediction and stuff, then there will be issues. So this is not a perfect design. Right? Also, there's another issue. Who can spot there's like what happened? Let's try it if you have the code. What if you now do the training again? So when you train it 2 times, right? So let's do it like train. So it said it's training in the background. So what's going on here is a mess. So what's happening is actually now there's 2 model training in the background. So if now we do info, because now there's 2 model training in the background. So again, this is another problem we have in our current design, which we have to solve later in the exercise. Yeah, okay. So far, so good. Any more questions? The number of background tasks? Right now, I'm just checking if, so I'm just using a counter to check. I'm not sure whether you can maybe background task if you go to the Fast API documentation, because I haven't checked it before. So maybe check if the background task, you can have a method to see how many are running. But I haven't checked it, so maybe you can have a look if you're interested. So Fast API documentation. So if we go here, so this is very good. So again, like, you know, if you have a lot of questions in the future, you always go back here. So this is the class. So it has function, attribute. So you can add task, but it doesn't have a method to show, but maybe dot func will show you what is running, maybe. I'm not so sure. You can try it yourself, actually. Yeah, have a try. Okay. So far, so good. Any more questions?
Can we retry the background task if maybe some task fail?
The background task failed?
Yeah.
What happened if the background?
I don't know.
I think in this case, if the background task failed, it will just failed in the background. So again, like I don't think it will collapse the whole thing, but it's just that, you know, maybe you would get something. I haven't tried it again. There's something you can try at home. Okay. So now we want to improve our design. So now it's like I told you there's a lot of issue with our thing. So another thing, what we could do. So before it's like one colleague proposed doing it that way. So this is the second colleague. The other colleague proposed, oh, let's use lifespan event instead. So what is it? Okay, so let's look at it together. So now we want to have a prediction endpoint. So because, you know, so far our application is quite useless because it's just train the model. It doesn't do anything else. So right now we want to add the prediction endpoint, right? So let's add the prediction endpoint. This is a little bit more complicated because we want to upload the picture. So this is how you make it use Pillow to upload the picture. Did here. Okay, so hopefully this will restart. I hope. So the thing is that it doesn't know that. Okay, now I can stop it. So let's do this again. Do it here again. Yeah. Right. Okay, starting now. So now, okay, so now I restart the whole thing. So I don't have any model anymore because I restarted, so there's nothing. So now what if I do the prediction, right? So if I go to, let's say, this time we need to use the documentation because we have to upload the picture. So upload picture, we use a post endpoint. So instead of get, it's post. So here, if we use this, we can upload a picture. So this is good. This is let you upload a picture. So let me find a picture that I have prepared before, which I put it somewhere here. It should be in the repo as well. You should be able to find it in the repo. But let me go back to the repo so I can upload it. Tutorial, yeah, here. Okay. And in the data should be, yep, test messages. So you can try any of these message images. So open, and now I would execute. And then now you see we have an error because we haven't trained the model. There's no model. It's like, it doesn't work. So the whole thing failed. This is not good. So we will fix it now. So how to fix it? Now we would use a async context manager here to create a lifespan event. Okay. So what this lifespan event does is that when you start the application, it will do this. So it would run all the things before you. So now before you, we have training. So what it does, it will train. So it will still be very slow in the startup because this time, this design, we also train before the start. But then we can guarantee when someone runs predict, then it's already a model there. So this is what we do. And also the benefit of doing it is that because anything after you will be run when we close down, when we shut down the application. So now, imagine you have a lot of model that you have trained and they're all very big. It won't use up all the resources. You can just clean it up. So this is the benefit of doing it. It's very simple. You just use the context manager here. So we put it in our code. Here, put it together here with the fast API thing. And then I create this before I create fast API because then I have to tell fast API to use it. So, right. And then now I can do. So the fast API lets you put in a parameter called lifespan. And this will take in a lifespan event that you created with the context manager. Do that. So now let's save and launch. Oh, so you can see it's already training. So I was like, oh, I can't stop it. Okay. Anyway, so yeah, like so now you can see that it's not application shut. So you can see it's not completed because now it's in the. We are now in the startup process and it's training the model. So we are actually in here, in here. So now the endpoint won't work yet. So if you go here, you know, this is, again, this is not working. You can see the spinning. It's not working. And if you try to go to the Swagger UI, it also won't work. Yeah, it's also spinning. It's not responding because we are still we are training the model in startup and it's still training. But now when we do the prediction, we won't have a crash because once your application is accepting requests, then at least one training has been done. So there's at least one model that has been trained. Okay. Yeah.
Can you fix this training process if there is nothing change to the data model or something, make the training process faster, the insertion process faster?
So you mean load in a model from?
Yeah, I mean catch the training result.
Yes, we would do that actually after. So we would actually do a process that we save it and then load it in instead of every time training. Then, because yeah, this is also not a very good design. So we are step by step getting there. We are learning more tricks, you know. So yeah, but that's a good point. Like that's what a normal, you know, reasonable person would do. So this is just a team discovering of this tool. Okay. All right. So far, any more questions? Yes.
If I want to do an automation, right?
Of automation. Yeah, you can actually set up a con task. So it's kind of a bit out of scope of this, yeah, but you can use a con task to do that. Usually, yeah, if you have server, you just set it to do it. But again, we can discuss it after. It's a bit out of scope. Yeah. So, what time is it now? Oh, we only have 3 minutes. So I'm afraid I have to. No. Oh, wait, no, we still have half an hour. Sorry, my bad. Okay, we will keep going. But we have a lot to cover, so I'm like a bit worried. It's like, oh, we are running out of time. Okay, don't worry. So now we have. Yeah, so now it's training. It will start, but that's one thing to do it. Like we'll keep improving it until the end of this workshop. But then, like now, there's another thing we want to add. Another functionality is that like, what if I want to retrain? So now I only train the model with the standard data that I was given it, right? So if you look at the code. So here, the data that we got is actually just the standard from the MNIST data set, right? So what if I have extra data that I want to train? Because sometimes you want to fine tune your model. Like let's say you have a suggestion engine, and then after the user, you know, work like using your website, you collect some information about them. You want to improve your model. Then you have to do training after it has been trained. So now let's change our code so it can be done that way. So now, instead of the training always call in those this data set, what we will do is that, so if we have input some data, then it will use that instead of loading the default. If not, then it will just load the default. All right, so let's put it in here. So if it's then loaded, otherwise, yeah. So I don't need this anymore. This should be, yeah. And then next we have the, also we need not build the model again. If we already have a model, we just take the model. What we do here. So we should, before building this, we should like see if we already have a trained model that's ready to go. All right, so let's put this here, and then this, I would put this into the else. So if there's already a model, we'll use it. If not, then we'll just build a new one like that. Okay. Yeah. So also now the training endpoint need to take in a the images that we want to retrain. So we would update the design of this. So it's more complicated, but it's mainly just like image processing. So I won't go into the detail again. So put it here, right? Okay. Oh, actually, I do need those. Check. Yeah, I should put it after pillow because I need that. Always put your import at the beginning, but I'm just because this is a workshop, so it's a bit like crazy. Don't do it like I do. Put the import at the front if you can. It's just easier for people to see this way. Okay, so now with this, we would have we can take multiple file. So if this is working, I hope this is working, or I stop it. Okay, I stopped it already. So let's start it again. Let's see, importing. Okay, right. So it's doing the initial training. Anyway, but like, oh no, I have error. Let's see if I can. Maybe so far, like because it's training. Anybody have any questions? More questions? Is the time to ask questions? Okay. So yeah, basically what we did is that we would now take multiple files. So this is a list of files. So now we can have multiple files for training, because before when we do the prediction, we only predict on one picture. We don't predict on more than one picture. This one is just multiple. So that's why we did it like this. Okay. And then afterwards, when we train, so in the background task, .act task, you can actually have, so the first one is the function that you're calling, or coroutine because it's async. And the next are the variables. So these are our training data. We'll put it in there. Right, this is working, but I want to show you that like this is actually bad, because if you go to Swagger UI, now it's not working, Swagger UI, because it's not loading it, but you can try it yourself at home or something like that. You have to upload it one by one. So what if I have 1,000 training image I want to upload? It's gonna take you forever because you have to edit one by one. So that's why we have this bit. So what this does is just create a very simple HTML form that you could upload multiple files all at once. So I would just skip ahead to this bit, because then like every time it reloads takes a long time. So I'll stop it if I can. Okay. See if I can stop it, and then, oops, sorry about that. Too many windows. Okay. So let's go to add this another endpoint here. Add it here. So this is just an HTML page. You can see it's just an HTML here, the content. So it's an HTML response, right? So, but the interesting thing is that the form actually is calling this. So instead of directly going to train, we go to this on our browser, upload, and then once you upload the file and call the form, like press submit, then it will call this one. So you can actually do that. You can use another endpoint to call another endpoint. So yeah. So let's hope this stops, and then we can start the new one, and then we can see it works. So far, so good. Any questions? Good. Okay. Right. It's gonna take a while because it's training. I could have stopped it and like see actually. Oops, sorry. Let's see if I can temporarily stop this. Maybe I'll temporarily stop this. So now it doesn't train at the beginning, but we just want to see the Swagger UI, so it's fine. But let's hope this stopped. Okay, let's come on. And also the extra challenge, you can try all these at home, like I said. Otherwise, like 1.5 hours, we can not do all the extra challenge. But if you're like, you know, you already understand, then like maybe you can already try it now. Almost there, we're almost there, we're almost there. Okay, stopped. Okay, this time it won't train because I have. Right. Okay, so now we can look at our upload interface. So for example here now, oh, okay. So now for example, you see if I go to predict, I can upload multiple file. No, not predict, sorry, train. I can upload multiple file, but you have to do it one by one. Like you don't want to do it 1,000 times if you have 1,000 pictures. So what we do is that we have added the upload endpoint. So this one, you can upload multiple files. So I already have a zip file somewhere here, which you can download and upload. There's 1,000 pictures in it, so you can use those. But like even here, let's say like if you can upload like multiple like this. So then you can do it. But I'm not doing it now because I haven't trained the model when it starts. I just want to show you this. So yeah. Right. So we have around 20 minutes. So what we'll do is that we would, we may not have time to look at Docker. So anybody who is not familiar with Docker and really want to look at Docker? No? Okay, then we would do exercise 4 instead of Docker, so because we may not have time for Docker. So, so exercise 4, so the design seems very good, but we have one last problem is that we don't want to, because right now you see in our code, here, when we train the model, right, we call the train, and then inside train, it will take the last one in the list to train. What if now I do the same thing, like I train it 2 times, like, you know, the 2 trainings doing it in the background at the same time, then it's bad because it's changing this model. 2 processes are changing this model at the same time. Actually, not at the same moment, but they would alternate. Like this one will be changing it, this one will be changing it, so it's a big mess. We don't want that. So that's why we now would do a improvement of what we have right now. Is that this time, what we would do is that we would save our model in the disk. So this also helps us when we start the because like remember we were training very slow, right? Like, oh, we are waiting for it to train to like restart the application. So right now, when it sees that there is a model that has been saved in your disk. So actually I have some here. So this time, like, you know, I already have some that I have been training before. I can just load it in and use it. So it's quite good. But right now it won't load those because like it needs to be have the file name in the list. I don't have, but anyway, but this one is actually like all the model you train. It won't save in memory. It will be saving in the disk. So that's actually one way to do it because then then you won't change both of them in memory at the same time. But what you do is like you would make a copy. So each process will make a copy of your saved model and then do it, like have their own version of it. So it won't be changing the 2 things together. So let's do it this way. And then, yeah, I have to change this here. Where was it? If the ML model is bigger than 0, it's this one here. So instead of taking it, I will load it in from disk. And then after fitting, I also will save it in disk instead of just like adding it in the queue in memory. So do this instead, right? So there's something wrong with this one. Did I missing the close? No. One sec. Doesn't like it. Because I don't have model name. 1 second. Okay. So now it will just like load the model from, you'll see if now we do the training again. So let's do the train. Let's see if we can do this. Because here, okay. Train model, I don't have the files. Okay. I have to, sorry, to fix one thing because I have, because I know I have forgot to. So now I have to start training at the beginning. But after you train, actually you will see that we will have an extra model saved here, like one of these files. They are saved in Keras format, so you can't see it. It's a bit of a mess. It's like it's in Keras format, but yeah. But then actually after you train, you will see an extra model here. So if you're following, you'll see that now you have a model. Yeah, so the extra challenge is actually like how to make it, how to load these files when you have it already, then you don't start it every time. But right now it's still starting every time. So how do you do that is, I'll leave it to you. So it will save time when you start up this time. So for any questions before we move on? Yes?
When you train the model,
Mhm.
there's like 15 process, the training process. Then we make it faster, like to train all of it at once instead of one by one.
Ah, that's what you're talking about. Is more like kind of parallel processing, but that's actually not in the scope for this because that you may need to. So it's not done by Fast API actually, like because again, like Fast API work mainly with concurrency, so it's using async code to put the background task at the background, but it's not running parallel actually. It's still like it's just when it's waiting, it would do something else and it would do something else. But what you're mentioning is like, oh, can we make it into parallel processing? So it's just like trade all at once and then combine the result together. Fast API doesn't do that. Yeah, yeah. You may have to. Maybe like because I think Keras and TensorFlow work with GPU, so maybe like or multiple GPU, you have to look into that, like in that direction. Yeah. But right now it's slow because it's a demonstration. Like, of course, this is not like what you would do in real life. Yeah. And also you have, yeah, you probably would save the previous result in disk as well. You won't train it every time. So all good? Who want to do the extra challenge to write the code so it like read this model instead of training when you start up? You can actually just like add a. So I will give you a hint. You just go to the background task here. So instead of this, so here you would read the save models here before you train. So you have to read the save model here before you train in your lifespan event. So maybe try this now. It should be quite easy, quite quick. Try to add some code here so it will read all these models that you have trained before. So next time when you start up, you don't have to train it again like I do here. It's super slow. We're almost finished training. Then you will see we will have a new model there. That is, oh, we have an error. What's going on? I forgot to import daytime. Okay, I forgot to copy and paste. Okay, I won't retrain it again, but you can try it yourself. Yeah, it's somewhere. Yeah, I think I missed it when I copy and paste it. So, where is it? Yeah, it should be here. From daytime input. Oops. It should be like from daytime import time. Yep. Anyway, it should be like this. Okay. Do you want me to quickly go through the Docker bit, or is it okay? You don't need the Docker because it's very simple. It's just a Docker file. If you already have experience using Docker, then you will find this very too trivial. But so can I have a show of hand who want me to quickly go over the Docker before we end, or do you want to try the extra challenge or ask questions? Who want to do Docker? No? Okay, then keep on the extra challenge that I have added for you. So there are also previous extra challenge as well that you could do. So, and then try it out and then ask questions if you have any. And we have 10 minutes. Yes. Yes, the U is, so basically this lifespan event is like the name said, is they're running for the whole lifespan of the application. So the U is actually yielding the rest of your program. So like so this is how you work, right? So it will run until yield, then it will like go back outside one layer. So this lifespan event is that when we start so you see the line fast. Where is it? 1 second. So you see the line like fast API here. So when fast API start, then it will start this. But then when it's yield, then it will go back to fast API, and then it will go the rest of the thing. So when fast API is done, right, it's closing down, then it will go back into here. So it will come back to the after yield, and it will finish the rest. So that's how you work. So normally you can like use something. So like it will return a value, and the next time you call that again, and it will continue from there. So, but now we are just like using nothing. It's just that at that time, this function will stop and then go back one layer, get back the control to fast API, and fast API will do fast API thing, run your application, everything. And then when it's done, when you close down, then it will go back inside and do the cleanup. Yeah, so it's like that. Yeah. Yes. Question.
I'm a little bit new to Python actually. Just wanted to know if what if the training data comes from, let's say, stream. Like you showed us the example from page files. What if it comes from streams like KSQL or Kafka or something? Can we integrate it into a fast API?
Yeah, in Fast API, actually, there is a file stream as well. I think I didn't go into this. So like now you see the file upload, but actually there could be a file stream as well. You can go to the documentation and see. I think I put the link of the documentation in the the README file. So if you go back to that session, you go to the documentation page. It will show you this. Because like there are file and upload file, there's also the, so I think instead of using upload file, you use file, then it's a file stream. You can also have multiple as well. So yeah. Question or okay. So I've been told that we have to end now. So let me wrap up. So thank you very much for coming to the workshop. Because like everybody's like level is different, and I hope like you can still learn something. And then there's also, you can always come back to this page. It's on GitHub. I won't take it down. You can always come back to refer to it. If you have questions, I'll be here again like tomorrow, the day after tomorrow, I'll be here so we can talk more about it. I have another workshop this afternoon about using Python and writing Rust code. Is yay. So feel free to join as well. But anyway, I will see you all around, and thank you for coming. Oh yeah, the mic. Thank you.
Welcome.